But it's okay. All the video I already provided there in our e-learning. Okay, where is others? Maybe, okay, while waiting for them, maybe we can go through a bit. See our early module 4.0. Wait, Wow, too many. Okay. So I'm going to share my screen now. Okay, let me start our module 4. Before that, I'm going to push another reminder to others. Okay, in our module 4 will be covered also for our test 2. So by today maybe, or tomorrow I go class. Yeah, morning session can. I'm going to also doing a recording for module 5 later on. So everything I will just push to your e-learning. But for module 3 and module 4 will be covered for your test 2. So it's very important for you to watch and go through all. Okay. What we're going to look into our module 4 is mission instruction characteristic, type of operand, addressing mode, instruction format. Dia tak terlalu banyak. It is just a compact one and it's related to your module 3. Just now we already looked into module 3. Okay, so the most important, you need to know the relationship between your higher level language, assembly language, and machine language. Okay, these three you need to know how you're going to relate with each other. What is low level language and what is the higher level language? From this high level language, which is like your C programming, your Python, your Java, and etc., how you can convert to your assembly language, or can it directly convert to your machine language? Okay, why you need to have machine language? Your laptop, your computer, they didn't understand the one that you like typing, move, add, sub, blah 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 blah, whatever that programming you writing up. Our computer, our computer or our machine did not understand. So that's why from your higher level language, you need to convert to your machine language, or maybe you can convert to your assembly language, and your assembly language also can later on to convert to your machine language. Baru your computer, your machine can understand apa actually you want them to do. So you can go through this. Okay. Now you need to know what is compiler and assembler. Okay, if you want to convert, you ada Java, you got a Python, you got C, you need to have a compiler. You compile using your compiler and it will convert to your machine language. This is direct. From your C, you have a compiler and it will convert to your machine language. And then your computer will understand. But if you want to compile it and you convert to your assembly language, you can have your C programming, Java, Python, whatever, C# and so on. You can compile and convert it to your assembly language first. From assembly language, Or maybe if you don't have this one from your assembly language, now you learn on assembly language, right? You write your coding, you write your programming. Our assembly language will be converted to machine language using assembler. We're going to assemble. We're going to assemble using our assembler. So that's why in question they will like mention what you need for you to convert from higher level to machine language. So you need to know it's going to be using your compiler. Or from assembler, what or what is the things that you need. So from assembler, you need to convert to machine language using your assembler. So this is the declarations that we already gone through last time. I already provide the video. And you can basically read what is the function and which one is much faster. If you have here for higher level language and assembly language, you kena tahu, you need to know what is the difference between each other in terms of their speed, their maintenance, their portable. So what is the difference between each other? So you can see here, higher level language is much more faster if you compare to assembly language. Why? So later you can see kenapa and why is faster, because you need fewer lines. If let's say I give you direct example, alamak jauh pula. Okay. Here is your assembly language. You have, let's say, 3 or 4 lines here. But in your C programming, in your higher language, maybe you just need one single line. So that's why is your computer just reads satu line, okay. Then you get the similar output in whatever you did in assembly language here. So that's why it's much more faster. And another one more thing, it easy to maintain. Why it is easy to maintain? Because you ada satu line saja. You have a single line compared to assembly. Let's say you have 3 lines here compared to 1 line. Of course, it's much faster. Of course, it's also easier for you to edit, to modify. That's why it's mentioned. The advantages is maintenance is much easier. And another one things, it's portable, because you can easily modify to others type of programming. Daripada Java, from Java, let's say you want to convert to C programming. So mostly their commands, their instruction mostly like universal, so it can be used to many programming. That's why it's portable. While for assembly language, the program are not portable. Why assembly language? So instead of having like many disadvantages if you compare with your higher level language, but kenapa, why you need to learn on assembly language and why you need to use this assembly language? Kenapa, why don't you directly go to higher level language? Because you sit over here, there is a lot of advantages, right, using your higher level language. So the one that you need to have assembly language, because it is accessible to hardware, because it's directly can convert using your assembler to your machine language. And then it's space time efficient, which is it is easier to understanding the source from in efficiency, tuning program performance, and writing compact code. So there is other few of advantages for you to use assembly language. Next, in terms of more theory, in your microcomputer design. This one later you're going to see also in your section 5.2 module 5. But this one is just an overview. What is the block diagram of your microcomputer? Of course, last time you did see you need to have the input, you need to have the processor or process, and then you have the output. In between, you need to have also the storage. So here there is a storage, your input output device, your CPU, and you need to have the interconnection between each other using your buses. In here, similar to your previous module, module 1, module 2, module 3, there is the function of each element in your computer, in your microcomputer. So you need to remember. And basically, if you already understand in your previous module 1, it's easy for you to know because it is basically similar. CUALU, what is the description? Now you look at clock. I already mentioned, if you already watched the video I provided, you can see that I mentioned about clock, and normally you learn clock in your digital logic subject. If you still remember, you learn on positive clock, negative clock. So all of that is under your digital logic last time. But of course, physics also you have learned about clock, let's say on the cycle. So from here, the repetition wave, it means that one clock, then you have another clock. So you can have from the one starting point to end point, and then after that, it will repeat. So it called as one cycle. And you need to know one cycle in terms of the time, or we call it as period. And how about the hertz also? There is a correlation between each other. Why you need this clock? If you still remember in digital logic subject, you need this clock, positive clock, negative clock, into trigger an event. Okay, let's see. You need to know the correlation between each other from starting. You have a fetch, decode, fetch operand, execute, store output. Mana dia punya flowchart tu? Sekejap saya cari depan. Okay, it's after this. So here, no need for you, I already mentioned, no need for you to remember everything like this simple CPU block diagram, but you need to understand the activities for fetch, decode, what is the activities. And this one is example only for your memory read cycle. You got clock here. So starting from here to here, it is one cycle and then continues. And when you have ADDR, what is the function of address? And then your RD and also your data. Let's see the step here, which is colored with this picture. You have cycle 1, which is your address bus ADDR. You can see here. And then you're going to place it on your address. That's why at the beginning, you're going to have triggers in your address here. Second cycle, you got the read line RD, which is going to set to 0 there. So this is just explanation what is happening in this memory cycle, read cycle. Maybe if there is others question, they give and provide with different, but This is the by default. Cycle 3, CPU wait 1 cycle for memory to respond. Cycle 3 here. So you can see it's wait for your RD, and then you're going to trigger your data there at your cycle 4. There is no question for this step because this one is for your understanding and it relate later on for your module 5. But this one is important. About your listing file. What is inside this listing file? About your map file. Because it's going to like flow. Upper flow dia when you want to try to execute some program. How program runs. Bila you double click dekat Microsoft Word, when you double click at your PowerPoint, when you double click at whatever program that available in your computer, what is basically flow is happening, because you just see, okay, when you double click and you can see some loading, but sometimes if your RAM is faster, you can like see it's directly open, isn't it? So inside here, before you can see the output, before you can see the word Microsoft Word are open, so when you click open, so it's going to have the source file. It's going to have a source file, and then it's going to assembler your source file. You punya execute program kan. So you're going to assembler, and it's going to create two files. One object file and one is listing file. After you have this, it's going to move to your linker. This one is linker. That's why tadi dia bagi got error, right? If your linker path is different, it look into your library. That's why I mentioned you have library error. What tadi 1104 So if your library is not in the linker file, your path is wrong, or your part is different, dia read dekat part tu berbeza from your link library, then you cannot execute lah, you ada error. But if it's successful, it's going to create your map file, and then it's going to execute file. Execute baru it's execute. After that baru it's load. After it load, of course lah you nampak you punya Microsoft, you punya adopt whatever functions or program that you try to run. So you need to know step by step, from step 1 until step 4. And this is the one that I mentioned inside listing file. What is happening? What is content in listing file? So you got source code, addresses, object code, segment name, symbol, and blah 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 blah. So example, you can see add sub.lst. So this is a listing file. The example of listing file that are available, it is here. And another one beside here, you can see this one. So normally you can see only this, right? When you are doing your coding and etc. But in the listing file, it got this. So that is the content that you need to remember. The source code, the addresses, object code, segment name, and your symbol. Okay, another one I mentioned that you need to know on your map file. What is the map file? What is the content inside your map file? From starting address to your ending address, the size. and also your segment type. So normally if you open your project, you can see there is the .map. And after that, tak ada lagi tunjuk. Okay. So that is the things that you need to remember. And ISA level, okay. Under this ISA level, you need to know in terms of the correlation between your software and also your hardware. So this is your ISL level. When you have example, okay, dulu the previous compiler that you have is Potent 90 program, and there is another example of C program. You need to compile to your ISA program similar to your Potent 90. You have also a compiler to compile to your SIA level. Then your ISA level yang akan conduct and communicate with your hardware.
Doktor, yang ni ialah yang circuit tu ke, yang no and so on tu? Dia punya user flow, is it?
Apa gate?
Ya, sebab dulu masa saya belajar digital logic kan ada no, NAND gate.
Tapi yang ini dia tak ada kaitan dengan gate.
Okay.
Hmm.
So yang ni apa benda ni actually dia punya?
Okay, ini you punya programming. Let's say you punya programming C programming atau apa-apa programming.
Okay.
And then lepas tu you akan convert to your machine learning kan? Machine program, machine language. Okay, so that is the purpose of ISA. ISA ni dia interface sebelum you communicate dengan you punya hardware. Hardware you, keyboard you punya computer. ISA akan program execute you punya machine language to your hardware.
Okay.
Then barulah you punya hardware tu dapat berfunction.
Okay, doktor.
Okay.
Thank you.
So here you have about what else? Okay, elements under your machine instruction. You have the operation code, which is opcode. This one will be covered on your test two also, related to the function of move, add, sub, and then opcode ni there is several things that you need to know. After this we're going to look into whether the minimum and maximum of opcode, source operand reference, result operand reference, next instruction reference. Okay, let's say you have a very simple portion of assembly language here. This is your operation code, or we can call in a short form of opcode. And this is, if you still remember, this one is destination, this one is your source. This is the example yang paling simple what you need to know in your assembly language. From somewhere you want to send to this one, which is you move from total, you're going to move to your destination, which is your AX. Then you remember back, AX ni berapa ya? Is it 8 bit? Is it 16 bits? So this one is 16 bits. If you still remember, this is also 16 bit, this is also 16 bit. And this is 32 bit. Why you need to remember all of this is in term of your table just now. 16 bit berapa? 2 box. 32 bits for your EAX is going to have 4. 1, 2, 3, 4. 4 box. So that is the thing why you need to have that. And also in term of, let's say, AX. If let's say dekat sini total kan, it's mentioned from total to your AX. Let's say total dekat atas ni, you dah declare. Of course, you're going to declare total equal to 1, 2. Let's say 1, 2. And you know AX is 16 bit. So you're going to have 2 boxes. Total, you ada 2 hexadecimal. So you're going to grab this value to be fit into your AX. Jawapan AX you adalah 1200. Why 00? Because it is 16 bit. In your total is put 1, 2 hash only. And sometimes dalam soalan dia tak bagi you in term of boxes, you kena write on AX equal to macam you punya output dekat you punya Visual Studio, you're going to have 0012. For EBX, kalau lah contoh benda yang sama which is similar value 12 but kat sini dia letak EAX. What is your answer for EAX? Your EAX will be equal to 00000012. 8 bits, 16 bits, 16 bit total is 32 bits. So that's why you need to remember on the size. Jawapan you, kalau misalnya you tulis 1, 2, which is of course hexadecimal kan, 12 je you tulis kat sini, jawapan you salah sebab you need to put on the size also, which is 00000012. Sama juga dengan your AX, although you know, kan jawapan dia total kat sini is 1, 2, which is, okay kita panggil 12 lah, let's say 12 here. Jawapan saya betul lah 12. It is not, because supposedly you need to put 0012 occupy all 16 bit. That's why you need to remember on the size. And another one is source operand, which is immediate value. You dah tahu this one is from source, which is you need to declare dekat atas sebelum ni kan. Kalau you tengok you punya programming assembly language, dia ada declaration part here. So you pick from source, which is you declare dekat atas. Tapi you can also have your immediate value. You have 2, then directly you put here 2 inside your AX. So this is the source operand with immediate value. But all of this also you will learn addresses, immediate addresses and etc. later at 4.4 I guess. And yeah, this is addressing mode, addressing mode which is at your section 4.4. You're going to have main and virtual memory. You got over here processor CPU register, immediate and input output. And the example here you can see, this one is inside your memory. This one is your register. You can see register. This is inside your memory, type of storage that you use. Operand under your memory. This one is your register. Operand of your immediate value. Operand from your input output. You can see read INT. You kena masuk key in. Key in kan you punya value from your keyboard. And what else? Next instruction is, okay, this one is looping. Looping. You're going to go for 0003 back. Jump to target. So if you want to see it clearly, you buat one by one. You copy this and then you put to your assembly language, you execute these sentences and then you direct and then you can see the value of your EAX. Of course, totally you kena declare dekat atas sebelum ni. Then you change the value, you play around with the value and check after single line, what is your answer. Instruction representation, okay. This one is in terms of a simple instruction format, berapa bit you going to have. Your opcode yang you punya move, you punya add, you punya sub and etc. How many? It is 4 bits. And then operand reference 6 bit, operand reference another one is 6 bit. You punya let's say example move EX, let's say here total. So this one is just a example only. So a simple instruction format. So it can be extended depending on your instruction. So let's say you can see here you got the opcode and what is the function. What else? This one is still under as example, your opcode. Okay, every single you can see here, your ADDR. Kita nampak, we as a programmer can see ADDR, but our machine can see like 0001010. Okay, this one is example I tak tahu sama ada. Okay, this one maybe load. For your load 10001010. So this is the opcode for this. In terms of symbol and representation, the one that we can see, dia macam ni. This is example how you're going to differentiate between instruction type on the data transfer because we use the load. And then the opcode in terms of machine understanding of machines programming, and a symbol representation, and the description. Transfer content of MX to your register MQ. Transfer content of memory locations of AX. And then you're going to transfer to your MQ register. During executions, okay, this one is not important. Okay, total staff. Okay, this one in terms of programming. Instruction type. Okay, all of this video I already recorded and uploaded to your e-learning. You can do a recap, and then this recording also I will upload later on. In instruction type, this one is important. Okay, you need to remember there is 4 type. It will cover in your test 2. Dalam soalan objektif ke, part 2 ke, it's going to ask you related to instruction type. Whether the data processing function dia adalah arithmetic logic instruction ke, what is the data storage, what is the data movement, what is the control.
Doktor, test tu objektif juga ke macam mana ya? Atau macam test
Sama macam test 1, part A dengan part B.
Pak B jangan susah sangat lah kata.
Part B,
Seram itu.
part B as I mentioned, kita tak buat susah-susah, but you need to fill in the table. Lebih kurang macam tu. You need to fill in the
Table macam ni ke? Macam contoh doktor akan bagi table-table macam ni ke?
macam tadi yang sekejap table. Yang ni saya nak ajar tau sebab ni ada cover juga dalam test tu. Sekejap. Mana table ya? Jauh pula ke bawah.
Jauh platform. Banyak
Yang macam ni. Table ni we will give you the initial value.
yang calculate tu.
Offset tu kita akan beri macam ni, and then kita bagi you program. You need to fill in. You need to fill in.
Dan ni kalau satu calculation salah memang salah lah sampai bawah.
Ini bukan calculation. You how you going to store? See? Dia tak ada pun dalam add ke, sub ke, move ke, dia tak ada. You just need to store. You need to have understanding how you can store. You guna apa tadi? Little Indian order. Kalau you salah in term of size, you salah semua. So kalau you mulalah dari atas tu, kalau ada yang tersilap satu, dia memang akan salah lah. Tapi kalau you tahu size dia, okay, byte ni maksudnya dekat sini satu je. Kalau word dia akan ada 2 sini. Kalau D word, dia akan ada 4, 1, 2, 3, 4 contohnya. Oh sorry, words ni dia ada 2 kat sini, 1, 2. And another one, 1, 2. 1, 2. So sampai sini. Yang sini adalah D word ada 4. 1, 2, 3, 4. So mana satu yang you kena ambil dulu? This one is directly. Senang je you masukkan kat sini. Kenapa tak boleh paste? Mana value saya? 1, 0. And dekat sini kita akan ambil 2, 3, 0, 1. Yang ini Kenapa 01? I dah bagi tahu you kena ada kosong. Sebab walaupun dia tak ada value kan, you kena put that kosong.
Okay.
And then sini you akan letak 3, 4. Here you will put 02. Kenapa 02? In front this supposedly ada 0. And you need to carefully check this should be hexadecimal. If let's say dekat sini dia adalah B, you need to convert 10 to hexadecimal, you akan dapat 2. 2, of course maybe you akan dapat 02 in hexa. So you carefully tengok juga dia punya radix base dia. So yang last kali ni you akan dapat 5, 6, 3, 4, 3, 4, 1, 2, and lastly 0, 0. Kenapa 0, 0? Because you need to have 4 box. 8, 8, 8, 8, 32. The D words is 32 bits per 46. Okay, so that is the thing how you going to store. From here, cara you masukkan di dalam ni. And one more thing, you kena tahu tentang macam ni, soalan yang begini. Sekejap saya cari dekat, okay yang inilah. So macam ni, you were given with this programming, very simple one. Dia tak banyak tau because dia tak ada panjang macam ni, ada sampai 5 saya rasa. Ada Mungkin lah. Tapi this very simple one, which is you ada 0 ni, you akan masuk dekat EAX. Nilai kita 0 yang pertama adalah ni kan? Kedua, you punya EBX ni ada value ni, dia akan masuk ke sini. Ketiga, you punya ECX, dia akan masuk ke sini. Move lagi sekali EBX punya value yang asal tadi ni, you move kepada EAX sekarang. So dia masuk ke sini. Dan you punya ECX sekarang ni, yang ini, you tambahkan dengan EAX you. 3 tambah 2, you dapat 5. So inilah, tapi jawapan akhir dia takkan tanya yang panjang-panjang ni, dia tanya jawapan akhir ni je. EAX berapa, EBX apa, ECX apa. Yang final je. Macam ni lah, yang output ni je yang kita nak. So you need to know how to read. Dia tak adalah terlalu complicated. The basic thing, add, move. Tapi normally in term of move aja yang banyak. So this one, the table, how you need to fit in the value. And then another one is in term of the value from your main prop. Okay, lagi satu I nak pergi dekat sini. This one is important. It should be quite similar to your Little Indian Order. Saya dah buat dah video dia. Tapi siapa yang tak tengok lagi, you can see this one. Okay. Mana. I guess you kena mula dari awal. You have here in term of stack, ini yang you kena fill in, which is in term of last in, first out, LIFO. Lebih kurang macam you punya Little Indian Order. When you have 1, 2, 3, 4, you akan ambil yang hujung dulu untuk masuk. Yang ini kemudian. So in term of LIFO ni, baru you akan masuk kat stack. When you have something value, you put in, let's say you ada 3, 4 tadi, 1, 2. You akan masukkan, you're going to make this in first. You call it as push. And then you push another one, you akan dapat 3, 4, 1, 2. Contoh example. When you want to pop, you nak keluarkan dia balik, dia akan dapat 1, 2, 1, 2, 3, 4. That's why you akan nampak kedudukan you tulis tu dia akan jadi 1, 2, 3, 4. Sebab bila you masukkan dalam you punya data stack, you akan masukkan 3, 4, 1, 2. You keluarkan yang ini dulu. Ini keluar dulu. Last in kan yang ini. First out. Last in ni yang akan keluar dulu. You akan popkan dulu, baru yang ini kemudian. Itu yang turutan you menulis macam ni. Tapi when you want to fit in, you going to push yang ini dulu dan kemudian baru ini. Ini yang last kali yang akan keluar dulu. So we call it as push, 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 push. And then we push and we're going to pop one by one. Lagi, okay. That's why where you're going to apply, kita akan apply dalam perkara ini, which is, first of all, you need to know on the expression 3. We're going to have in-feed notification and post-feed notification. Mesti akan keluar Mesti akan keluar. First kali when you have in-feed notification, you need to remember on left, right, left, parent, right. Apa maksud parent, apa maksud left, apa maksud right. So left, parent, right. Parent is normally on your tambah tolak darab bahagi arithmetic operation. Left and right ni is depend on your value, your for integer. So let's say you ada A, X, multiply with B, and then you add with C. How you going to convert it to 3? This is your in-feed final. Sebelum tu you're going to have left, one numbering, one value here, and you ada parents. So that's why you have this parent, left, parents, right. And then you ada yang ini menjadi left sekarang. Left, dia akan connect ke parents and then right. So this is the flow of in-feed notification, left, parent, right. When you change it from one, you dah dapat yang ini adalah satu left. Tadi yang ini left kan? Ini left, ni adalah parents. Ini you punya right. Then this will be your left again. Left, and then you have another parents and to your right. It's going to be your infix tu dia akan buat dekat yang bawah ni dulu. A, parents, right. A multiply with B. So this will be your another left. This will be your another right here. And this will be your parent. That's why this you're going to factorize it to be left. This is your parent. This is your right. But it's okay. You tengok dulu and then you're going to see the differentiation between infix and postfix. Now we look at postfix. Postfix a bit confused, but you need to remember it's going to be left, right. Baru you meet your parents. So we have, let's say here, yang sama, you were given with the equation yang sama from just now, example this. Tapi apa kita punya infix? Infix, apa kita punya postfix? For A multiply B plus C, infix kita akan dapat A multiply with B plus C. Tapi kita ada factorize because it will be your left, right? Okay, now we have phosphate. What is our phosphate for the similar example here? Finally, we will get this. But how? We will have A, which is left, and then we need to have right. From A, we're going to have our right is this one. A, right. After that, we will have parents. A, right, and then parent. That's why you have A as a left, B as your right, and then multiply will be your parents. Okay, that is 1. After that, you akan ulang lagi. You're going to have left. This will be your left side. Left, and then you're going to go to your right, and after that, your parents. That's why you have A, B, parents. This one will be your left. Go to your right is a C. Your right, and then parents. This is your postfix. So from here you're going to get your postfix. Before this, you're going to draw these 3. A, B, multiply, and then you have C, and then you have adding here. From here, left, right, parents, left to the right to parents. For your, just now, for your infix, you are the left, parents, right. This is your left, left, parent, right. That's why you have for your infix, A multiply B, you go to your parents, you get another right. Left, parent, right. This one will be your left, parent, right. While for your postfix, you got A, right, parents, left, right, parents. So this is your answer. So where you going to apply all of this? Sekarang you tak nampak ABC lagi, you're not going to see ABC. You're going to see in term of numbering. In term of your value, your mathematical things. So this is the one that will come out, I guess, in your test 2. Whether you're going to do the reverse Polish notification ataupun vice versa. From this, you were given with your infix, you kena dapatkan postfix. Maybe you're going to given with your postfix, you kena dapatkan infix. So let we see one by one. If we were given with infix, how we going to come out with our postfix? From here, we need to come out first with our expression 3. We have 1 plus 5. 1 plus 5. And at our right side, we have 8 minus, we have another one, 4 minus 1, and then 8 minus 4 minus 1. And these together, we're going to multiply. That is our infix. We convert it to our expression 3. Now, from this infix, we already expressed in the expression 3. We need to change it to the postfix. Kita kena ingat, we need to remember from left, right, parents, left, right, parents. So we have left, right, parents. So this will be your left now. Left, right, parents. And we need to have from left, we need to go to the right. If you still remember our tree here, you can see you cannot go to this one because this is parent. So that's why from our left here, we need to go to the right. So from here, 1, 5, plus this is left, right parents, and this will be our left now. We're going to go to the right, right, left, right, and then until we finish our right there. And we have parents. Left, right, parents. This will be our left, this will be our right, and then parents. So we have 1, 5 parents. This will be our left, right, 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 8, 4, 1, and then parents. From 1 until above is our parents. So here you can see step by step. Just now you come to see maybe. Then you can see here step by step. We have this. This is our left now. And from here, you have 8 minus 4 minus 1. Then we have multiply here. How you going to get the value using your postfix? Later on I will show you. But now here you can see from this we will get 6. From this we will get 3. And then this value 8 minus 3 you get 5. And lastly you will get 30 in terms of your mathematical. But how you going to put and feed it into your postfix? So for your postfix now, you can see here, you already convert into your postfix. So from your postfix, how you going to get the final answer? Left, right, you're going to see, you're going to feed in the value into your stack. Okay, I have stack here. 1, I will push 1 first. And then I have another one is 5. I'm going to push my 5. 1, I masukkan dulu. And then I have 5 here. And from here, after that, I meet this arithmetic, which is operation. When I meet operation, I'm going to pop. I'm going to pop, which is I tarik dia keluar balik. This will be 5. This will be my 8. This will be my 1. So here is the value. Saya punya tulisan tak cantik. Kita tengok dekat sini. Example. Okay. From here, I have this. I read from here from left to right. Okay. I meet 1. I push 1. I meet 5. I push 5. This is my stack from empty. And then I meet my plus here. Bila I jumpa when I meet my operation, I'm going to pop. I'm going to pop, which is I got 5 plus 1, which is equal to 6. When I have this value, I need to store first. The value I akan storekan dia. I'm going to push. I masuk dekat sini. So bila dah masuk ni, I continue balik. This will be 6 kan? I have 6. I akan pushkan dia dengan 8. Push 8.
Push 4.
And then I push 4. And then I push lagi 1. Until I meet this one, I akan pop. This will be pop.
So
So
answer keluar
4 tolak 1. So kita akan dapat value of 3 here. So 3 kita akan letak
bila
dekat.
pop tu 4 dengan 1 dengan 4 keluar kan?
Ya. Yeah. Pop tadi ini keluar, ini keluar. Ini adalah operation kita. Tadi kan? Okay.
Yeah.
Okay, so bila kita dah popkan dia tadi, balik tadi, kita popkan dia bila kita meet operation, then 4 tolak 1 kita dapat 3. These three we will push. Kita akan push dia ke dalam kita punya stack. That's why kalau you tengok yang tadi kita push yang value ni kita letak dekat depan sebab empty. Tapi sekarang ni our value inside our stack is 6, 8 and then baru 3 yang kita akan pushkan dia. That's why dia dekat sini bukan dekat depan. So you need to know kenapa dia yang tadi tu 5 tambah 1 you letak dekat depan. Tapi sekarang ni 4 tolak 1 you letak kat belakang pula. You need to see the condition of your stack. Just now when you adding this one, you dapat 6, your stack is empty. That's why you push dia dalam ni empty, dia di depan. Now you have here 3, but in your stack already exists 6 and 8. So you push, you akan dapat begini. So you dapat 6, 8, 3. And you continue balik sebab tadi kita sampai sini kan. When we continue, we meet again with our operation. So we meet again, so we going to pop 2 value. 8 minus 3. This one. Kita push, popkan, kita akan dapat 5. And we going to push it back into our stack. That's why we get 6 and 5. We continue back we going to meet with another operation. We will have 6 multiply with 5. That's why kita akan dapat 30. This final answer we going to push to our stack. And this is our final answer. So dalam satu stack tu, the one value only can be stored into your stack sebagai you punya final result. Maybe you can try the example. There is several example how you're going to play around with the infix and also your postfix. So for part B, I guess the things that you need to know on the postfix, infix, lepas tu you punya table tadi. Where is your table just now? Which is your value and also your offset. And lastly, you punya code. Tu punya. So the rest for your module 4, you need to do many exercise. All the exercise example that provided, you kena tahu. You need to do a lot of exercise. Mana? Dah terlepas this one. This on your memory inside. This is supposedly hexadecimal. In terms of your code, this one is simple things. When you were given with the value, this one, how you're going to store into your database. And when you have the code here, main prop, what is the answer for your AL, what is your answer for ECX for the final output there. So before our mock, maybe we can do like last time. We discuss together first. I think it's not too hard for our test 2 compared to test 1. This one is all the example already given with the answer. Tak lari. It's not going to be far from all the example given. No complicated like this. When you were given with all single thing, dia takkan very complicated sangat. It's just very a simple code like this, and you need to come out with the output. Macam tu je. This one pun macam banyak juga, panjang. Dia tak terlalu panjang and it is not too complicated in term of addressing. Dia direct. Any question? I guess I'm going to record extra video untuk yang next 4.3, 4.5 and our conclusion for module 4. Nanti you need to watch back the video, okay?
Doctor,
Yeah?
Doctor, we still have one more class only, Doctor, on 9th January.
Again?
We only have one more class on 9th January.
One more class on 9th
Only, yeah.
January.
We have only one more meeting.
February tak ada eh?
February
No,
dah.
don't have. That one will be our last class, 9th January.
I thought this.
Kita February dah final, Doktor. February second week saya rasa.
23rd January is the group 3 last class for group 3, Doctor. After that, minggu ulang gaji, 24 January until 5th February.
Okay, if that's so I need to speed up. Can I just I share the video? If you have any question, maybe we can have like extra class when you free. You can just directly mention where you free and then we can meet online.
Boleh, Doktor.
So because I think for test 2 it's okay. Kita boleh buat bila you free. Final je we need to follow the schedule, right?
Ya, Doktor.
So for final exam, let's say I guess end of February or early March. I don't have the timetable yet.
Minggu peperiksaan 6 Februari hingga 24 Februari, Doktor.
6 Februari hingga 24
COA
Februari.
bukan 23rd, 23rd Feb.
Dah keluar eh?
Saya belum check lagi.
Dah keluar. Lepas tu clash dengan saya punya subjek lain.
Bro, bila bro? 23 Februari eh?
I don't have timetable yet. Okay, if kejap ya, okay,
Ada echo, Doktor.
okay. So if let's say we can meet online for mock final exam, it will be okay for me. But I don't know whether you can do a mock or not with me because it is important for us to do mock before like a test, before a final exam. Can or not?
Ulang kaji boleh buat tak, Doktor? Masa minggu ulang kaji tu.
Masa minggu ulang kaji. Okay. So to speed up, I need to record the video. So every time I finish, I can WhatsApp all of you and then you can watch like at night or maybe weekend. Can
Boleh je.
And if you have any question, kita akan jumpa. You can request me bila you free and then we just meet online.
Okay, Doktor.
But for your test tu, kita buat mock dulu. Maybe 1 or 2 hours before our test. And then after that we go through our test. Lepas tu we discuss a bit about final exam. Can or not?
Can, Doctor.
Because me and Dr. Aida, we are worried for our apa we call perdana student because kita kena selaraskan dengan space. So we already discussed that we don't want it to be hard although it is final exam.
Yay. Lega dia.
Bila test tu Doktor?
Test tu supposedly this week tau supposedly, tapi kita dah anjak 1 minggu. You all dapat tak announcement? Tapi it is not final yet. Kita dah anjakkan 1 minggu daripada our academic calendar.
Maksudnya kita tambah seminggu lagi lah.
Supposedly sebab yang kita diberitahu, tapi it is not official from Senat. So every test, every assignment we need to, kita kena anjakkan 1 minggu. So last week student perdana semua tak ada kelas. So supposedly kita orang ada test tau hari ni, 2 test, tapi semua dianjakkan to be 8. So kalau student perdana,
So just prepare je lah kan. Sebab
Apa
kita
dia?
akan buat mock test juga nanti kan.
ya, tapi mock test dalam hari yang sama boleh tak? Boleh kan?
Boleh je, janji boleh discuss sikit-sikit, nampak-nampak sikit okey lah.
Sebab kita tak boleh buat macam hari tu kita buat mock test sehari sebelum sebab nanti kita tak cukup masa. So hari yang kita nak buat tu, hari tu kita discuss dulu mock test, kita go through several question together and then kita buat test sama-sama.
Okay, doktor.
Test untuk student perdana 8 hari bulan.
Oh, 8 saya ada test lain juga, subjek lain.
Tapi diorang dah anjak lah. Supposedly they're going to do the test today. But because we already extend 1 week, so perdana kena buat 8 hari bulan. So about final exam,
Kita 9 hari bulan kita ada kelas dengan doktor.
untuk saya tak kisah bila nak kena buat test tu. Tapi untuk final exam je lah, kita tak ada, sebab jadual yang sebelum ni already finalized I guess from school. But bila dah anjak tu, there is argue from them sebab ada cuti awal minggu March. Saya tak tengok cuti, but they said ada cuti, so susah diorang nak susun balik. Tapi surat senat tak keluar lagi. It is not official yet yang kena anjak tu. Tapi last time you dapat kan surat cuti minggu lepas? Space dapat?
Tak dapat doktor. We just refer to the timetable.
Oh, because Space tak dapat kot. Tapi in term of perdana, kita dapat cuti seminggu, minggu lepas ni, termasuk minggu ni lah. Esok baru kita start kuliah balik. So that's why dia dianjakkan semua assignment, test. Tapi final exam, diorang baru bincang untuk anjak. Tapi ada certain argue about, yelah nak susun balik kan a bit tough kan. So they said they're going to wait for Senate. But after all, that is not our responsibility, I guess. Kita punya tugas, kita kena ikut je flow. Test tu nanti upcoming next week ya. Before test tu, kita mock dulu, kita discuss together. Like chapter 5, 6, 7 semua
Next week.
saya akan.
Next week minggu apa? Hari Sabtu ke?
9 Sabtu kan?
9 Ahad.
9 Ahad Ahad. Okay. Boleh? Ahad pagi kan? Pukul 11 10?
8:30 doktor.
8. Okay. So
8:30.
pagi tu macam hari tu lah. Ingat tak kita discuss dulu together last time? From for our test 1 kan? So pagi tu kita discuss dulu, kita do mock dulu. Bila you dah buat mock, mesti ada question kan?
Ada.
So ada question tu kita discuss sama-sama and then baru kita decide lah pukul berapa. Let's say mungkin tengah hari ke after lunch ke kita baru start.
Okay.
Kita punya test tu. So untuk perdana diorang akan buat 8 hari bulan. So kita akan buat 9.
So cover topik apa tu?
3 dengan 4.
Okay.
3 dengan 4. So lepas ni saya akan
Final will be module 5.
final 5, 6, 7.
Oh, still at
5,
5, 6, 7.
Yes. 5, 6, 7 ada 8 I tak ingat. But mostly nanti I akan share juga final exam, final what? Exam sebelum ni, last semester punya exam. So mungkin kita akan discuss together macam mana, how the architecture look like, macam mana soalan final. Tapi you kena submit you punya lab juga. Nanti I akan combinekan you punya lab. Maybe kita akan buat 2 lab ke, and then a group project pun saya bagi simple saja. Tak perlulah susah-susah macam terlalu besar sangat project tu kan. Just a simple programming. As
Okay,
long
betul.
as long as you ada work dengan group tau. So dari situ kita akan give you a coursework mark. Okay.
Okay, doktor.
Okay, so anything nanti saya update dalam you punya WhatsApp. Please watch all the video that I provided. Notes pun I dah share kan dekat dalam you punya e-learning.
Ya,
Okay.
doktor.
Okay. So ada question you can WhatsApp me directly, okay?
Okay, doktor.
So malam ni nanti I'm going to share you the video. Please watch
Okay, doktor.
Okay, if needed, kalau ada keperluan untuk kita meet, nanti I'm going to inform in the WhatsApp group.
Okay, doktor.
Okay, so kita berehat dulu. Bye-bye.
Bye.
Bye-bye, thank you.
Doktor, petang
Thank you,
nanti ada lagi.
Dr.
Petang tak ada, tapi malam mungkin kalau misalnya you dah go through video, if you ada question, then keperluan kita meet.
Okay, doktor.
Okay,
Doktor,
similar
thank
ni.
you.
Happy New Year.
Okay, bye.
Thank you, Doctor.
Happy New Year.
Happy
Thank
New
you.
Year.
Yeah. Bye.